My name is Taro, and today I'm going to present our work, Learning to Ground Multi-Agent Communication with Autoencoders. The emergence of a language was a defining moment in human evolution, starting from which human societies began developing into much more sophisticated forms. The study of communication in multi-agent environments is critical for the same reason. It opens up new ways for agents to develop collective intelligence, improving their coordination and cooperation for a much wider range of tasks. An essential aspect of communication is that each pair of speaker and listener must share a common understanding of the symbols before any meaningful conversation can take place. For artificial agents, with the communication channel but without an agreed-upon communication protocol, this raises the question: how can meaningful communication emerge as agents try to maximize their utilities? The communication model that most closely resembles language learning in nature will be a fully decentralized model, where the policies of agents are independently optimized. However, such models perform poorly even in simple communication tasks or with additional inductive biases. As a result, previous works have resorted to using supervised learning, centralized learning, or differentiable communication to achieve success in communication tasks, making them much less applicable to real-world multi-agent coordination problems. We tackle this challenge by first making the following observation on why emergent communication is difficult in a decentralized multi-agent reinforcement learning setting. A key problem that prevents agents from learning meaningful communication is the lack of a common grounding in communication symbols. In nature, the emergence of a common language is thought to be aided by physical biases and embodiment. Yet artificial communication protocols are not a priori grounded in aspects of the environment dynamics. This poses a severe exploration problem, as the chances of consistent protocol being found and rewarded is extremely small. Moreover, before a communication protocol is found, the random utterances transmitted between agents add to the already high variance of multi-agent reinforcement learning, making the learning problem even more challenging. To overcome the grounding problem, an important question to ask is, do agents really need to learn the grounding from scratch through random exploration? Inspired by language learning in natural species, we propose a novel framework for grounding multi-agent communication. First, ground speaking through learned representations of the world. Then, learn listening to interpret these grounded utterances. This approach offers the benefits of allowing fully decentralized learning without needing additional architectural bias or supervision signal. Surprisingly, even with the simple representation learning task of autoencoding, our approach eases the learning of communication in fully decentralized multi-agent settings and greatly improves agents' performance in multi-agent coordination tasks that are nearly unsolvable without communication. The contribution of our work can be summarized as follows. First, we formulate communication grounding as a representation learning problem and proposes to use observation autoencoding to learn a common grounding across all agents. Second, we experimentally validate that this approach is an effective approach for learning decentralized communication in multi-agent reinforcement learning settings. Our communication model, trained with a simple autoencoder, can consistently outperform baselines across various multi-agent reinforcement learning environments. Lastly, we highlight a need to rethink how to address the lack of visual grounding in communication policies, where this work serves as a first step. Please check out our paper and project website for more details. Thank you for listening.